Ever seen version numbers like 2.4.1 or 1.0.0 and wondered what they actually mean? Today we're going to show you exactly what's behind the famous semantic versioning, also known as SEMVER, a simple yet powerful concept that affects developers, operations teams, and anyone deploying software. This is another episode in our DevOps series, and in under 5 minutes, you'll understand how SEMVER works and why it's so crucial for keeping your software stable, predictable, and well documented. And to break it all down with clear, no-fluff explanations is our expert from the Cloud Bootcamp, Herbert Pereira. Let's go. It's time to finally make sense of these version numbers.
Hey guys, welcome to another video here on the channel. In today's episode of our DevOps series, we're going to talk about an essential concept for those working in development and operations, semantic versioning. In about 3 minutes, you'll understand what it is, how it works, and why it's so important in our daily lives. Let's get to the definition. Semantic versioning is a widely accepted standard for naming software versions, following the pattern of major, minor, and patch format, 3 numbers separated by dots. You can have, for example, an application or a system with version 2.5.1, and each of these numbers has a very specific and crucial meaning. So, let's take a much closer look at each key part of semantic versioning. Starting with the major version, the very first number represents significant changes that can break backward compatibility. For example, if you have an application running on a version starting with 1.00 and migrated to version 2.00, this clearly indicates a radical change. Perhaps an API has been fully rewritten or some old features no longer exist. And in the middle column, we have the minor, which is the second number that indicates new features but maintains compatibility. So if an application moves from version 2.1.0 to version 2.2.0, this shows that something new has been added, but the features of the current version continue to work normally. Lastly, we have the patch, which, as the name clearly implies, the third number is specifically used for applying minor bug fixes and adjustments. So, an application that moves from version 2.2.1 to version 2.2.2 means that nothing changes for the end user in terms of functionalities, only occasional corrections that occurred in the application. But why is this so important? Semantic versioning brings clarity and standardization. When we look at the version number, we already know the impact of that change. This helps a lot when it comes to using pipelines, CI/CD, managing dependencies, and avoiding unpleasant surprises in production. In other words, in addition to better organizing the software lifecycle, it also improves communication between teams. So, in summary, the major is for big and incompatible changes, and the minor is for adding new features that remain compatible with the current version, while the patch is for applying minor corrections and adjustments. Simple, straightforward, and extremely useful. So, did you enjoy this quick piece on semantic versioning? If so, feel free to leave a like, subscribe to the channel, and comment down here what other DevOps concept you'd like me to explain in up to 5 minutes, and I'll see you in the next video.
Alright, thank you so much for watching this video, and then if you enjoyed this content, please consider subscribing to our channel, give us a thumbs up if you enjoyed this content, and then also please leave us a comment telling us what you think about this video and also the things that you'd like to see in a new video here on our channel, okay? And then if you're interested in mastering Move to Cloud, DevOps, and AI with our help, please check the links in the description as well. Hope to see you in the next video. Take care and goodbye for now.